You've heard about the periodic table, which contains information about all of the elements which make up matter in the universe. And in this video, we're going to review and introduce some information about some parts of the periodic table. And this is information that we're going to use as we go along through the year. So different periodic tables come in different forms. You probably have seen several different versions of it. There are many, many different versions. Here's one that has a certain color scheme. These colors are significant. I even think there might be a mistake in this one. I believe the element helium should have the color blue on it. But that's beside the point. The point is that there's certain information about the elements in this periodic table and a certain color scheme which provides us more information, and different people sort of do it in different ways. But what we're going to find is that the elements are almost always organized and placed in the same pattern of columns and rows. So here's our periodic table that the state of Massachusetts uses when it does its testing, and it is different color, some different information printed in different ways. It has names on it, not just symbols. But the elements are organized in a certain fashion on the periodic table in columns and rows. It's not just some list of elements from numbers 1 through 115 or so. This periodic table doesn't have on it the most recently discovered elements. So there are a few more that would be listed on a slightly more up-to-date version. All right. So, because the periodic table is organized in a certain way, into certain, so that certain things end up in certain places, the columns and rows are important. And the columns have a name. So the elements in a certain column on the periodic table are said to be in a certain group. So here are the elements in group 1A on the periodic table. And in a preview a minute ago, there are the elements in a different group on the periodic table. Now, you might have called a group a family in previous science classes. That's okay. We're going to use the word group, but using the word family is okay. And every column on the periodic table is a separate group. Of course, when we get to the middle, some people consider all of those to be in the same group. Some people don't. But all the way across, the periodic table consists of columns or groups of elements. Now, the ones that we're going to be mostly concerned with in our class are the elements in the 2 groups on the left and the 6 groups on the right-hand side of the periodic table. And there are a couple of different numbering systems. Some people number the groups starting with 1, 2, 3, and going all the way across with consecutive numbers to 18. But we're going to use a slightly different numbering system that might seem more complicated, but that will help us. So, by our numbering system, the elements in the first group here, the first column on the periodic table, are said to be in group 1A. So we have a number and a letter. So the next group is group 2A. And for group 3A, we jump all the way over here. So all of the elements in groups that are highlighted in yellow have a number that is combined with the letter A. And the elements in these groups here have groups with a number and the letter B. So the elements in groups ending in letter A are sometimes called representative elements. I'll write that word down here. Representative elements, so we can talk about them all at one time. Representative elements. Representative elements are in groups that end in letter A. And the reason we want to use this system, group 4A, group 5A, 6A, 7A, 8A, the reason why we want to use this system is because when we do use it, the number will help us to understand something about how elements bond with other elements and what happens to their electrons when they are combining or bonding with other elements. So we want to remember the groups with these numbers that are shown on this slide here. You may have noticed that these numbers down here, or these elements down here, aren't even considered to be in a group. All right, so the rows also have numbers going back and forth across the periodic table, and the rows are called periods. So these two elements at the top, hydrogen over there, helium over here, are said to be in period number 1. Oftentimes that number is listed as it is there. As we go down, the periods are numbered consecutively. There's period 2, period 3, period 4 has more elements than the ones above it. Period 5, period 6 and 7, here's period 6, whoops, here's period 6, and it's got not only the elements in the main part of the periodic table, but some of the elements from below are also included. Period 7 the same way. These elements that are printed by themselves at the bottom actually belong in this small space on the periodic table. There should be these elements should be slid apart right here so that these can fit in. The reason they're printed by themselves down here has nothing to do with science. It only has to do with the fact that it makes it easier for the printer and the publisher to fit more information on a page. So by putting them down here, we can print everything bigger and it's easier to read. But these elements actually belong right in here. All right, now, when things get organized in certain columns and certain rows, that is, certain groups and certain periods, the reason for that is so that things that have similar characteristics, common characteristics, end up in the same region of the periodic table. And so we can look for these regions and we can look for similarities in the elements that are there. And the first thing we want to do is we want to be able to tell the difference between metals and non-metals. So if you were very observant, you can see that this line here that's shaped like stairs is highlighted. It's a little bit darker than the other lines on here. Not so easy to see, so we have highlighted it in blue on this slide. We'll call that the stairs because it looks like a set of stairs, and it's the line that separates the metals from the non-metals. All the elements on the left-hand side of this set of stairs, they're highlighted here in green, with the exception of hydrogen, are metals. And all of the elements on the right-hand side, plus hydrogen, are non-metals. And that's going to be important to us. So we want to remember what that set of stairs, which we see printed on most periodic tables, what that set of stairs mean. Metals on one side, non-metals on the other. So here are those two things together, metals over here, non-metals over here. There's one bit of information added. Some of the elements that border the stairs have properties of both metals and non-metals, and they're called metalloids. But oftentimes, we're going to be in position of deciding whether an element is a metal or a non-metal with no other option. And in that case, we're going to use the line. Metals to the left, with the exception of hydrogen, non-metals to the right, and hydrogen, of course, is a non-metal. So metals and non-metals. Now, some groups on the periodic table, or some regions of the periodic table, have a special name because the elements in that region or that group share characteristics, and we want to talk about them all at the same time without having to list all the names. So the metals in group 1A are sometimes called alkali metals. And the elements in group 2A are called alkaline earth metals. So those names are kind of similar. You might guess that there are some similarities among those things, and you would be correct if you guessed that. But they are different, so they do have slightly different names. The elements, the metals in group 1A are named with a name that has one word before the word metals. The elements in group 2A are named with a name that has two words that come before the words metal. Metals, one word, two words, 1A, 2A. Alkali metals, alkaline earth metals. Let's shift our attention over here. Elements in group 7A are called halogens. We often talk about them together because they have similarities. Elements in group 8A are called noble gases. I've circled that in red here because the printing is kind of light. Noble gases are going to be very important to us. We will refer over and over again to noble gases because they will help us understand how things bond, how elements combine with one another. All the elements in group 8A are noble gases. The elements in the middle of the periodic table that are in groups that end in letter B are called the transition metals. And the elements that are normally printed down here at the bottom that really aren't in any group, that belong in this slot here, are called the inner transition metals. Here's those words over here, they're kind of hidden. These are the inner transition metals. They're highlighted in light blue there. So this slide sums up all of the names of regions that we want to remember. There are some others, but these are the ones that we want to remember. And this is a good place in this video to come if you need to review these names of certain parts of the periodic table. All right, why the names? Why the organization? The periodic table is shaped this way so that things that have similar properties end up in similar places. And that leads us to this statement here. Elements in the same group have similar properties or show a trend in a property. So this is a general statement about the elements in a group are being similar to one another. They're not exactly the same, otherwise they wouldn't be different elements, but they do have some similarities, and that's why the periodic table has columns and rows or groups and periods the way it does. Let's look at a quick example of that. Electronegativity is a property of an element that tells us how its atoms behave when they're bonded to other atoms. Can they attract electrons that are in a bond? And we won't dwell too much on exactly what electronegativity is, other than to use it as an example of the idea that things with similar properties end up in similar places when we organize the periodic table this way. So, the elements in group 8A all have 0 electronegativity. So all of the elements in this group have exactly the same property of electronegativity. That's not true of the other elements. They all have different electronegativities, but they are organized so we can see patterns. So if we move from left to right across a period until we get to we'll stop at group 7A, but when we move from left to right, you see that electronegativity increases, as this label and arrow tell us. So lithium has a lower electronegativity than fluorine. Sodium is lower than chlorine. And in general, the elements over here have lower electronegativity than the elements over here, up to group 7A. But even within a group, we can see a pattern, and that is that the elements at the bottom have lower electronegativity than the ones at the top. So electronegativity increases as we go up in a particular group. So that means that lithium or hydrogen have higher electronegativities than francium. Fluorine's electronegativity is higher than astatines. So by organizing the periodic table in this way, we can see trends and patterns that help us understand things that go on in chemistry. They help us explain things, and sometimes they even help us predict things. Electronegativity is just one example of how elements that are similar to one another or fit in a certain pattern go to certain parts of the periodic table. Thank you for listening.